So if I get this magnet on my head.
I'm Dave Bogart. I'm the Vice President of Research Programs and Industry Relations at the Ontario Brain Institute. So on behalf of the board members of the OBI, some of whom are here today, and a lot of our colleagues who are here today, and on behalf of our president, who actually can't be here today, Don Stuss is in London at a meeting of the Ontario OECD, planning for an event that's going to happen in September. We're excited about that, but disappointed that he can't be with us. Anyway, I want to welcome you to this first OBI event, highlighting the discoveries of Ontario's top neuroscientists, and it's held in partnership with the Globe and Mail, and we're thrilled that they are partnering with us in this way. OBI is a not-for-profit institute that was opened a short while ago in 2011, and it's funded by Queen's Park. We are one answer to a huge need and an even bigger opportunity. Mental health and addiction disorders cost Ontario's economy $39 billion every year. $39 billion is a huge number, isn't it? And it's a little hard to visualize, so I was scratching my head thinking, what can you get for $39 billion? And I discovered you could buy about 135 of those Dreamliners that Air Canada is waiting for. In fact, they've only ordered 37, so you could buy 3 times as many as they want. Anyway, to that cost, we have to add the very human toll faced by the families of people who were afflicted with autism, Alzheimer's, epilepsy, addiction, depression, and many other devastating brain disorders. So the $39 billion is for just part of the puzzle, the picture that we're trying to solve. Along with this huge need comes an extraordinary opportunity. Ontario has more than 800 neuroscientists, a huge bank of talent that is tackling issues of concern to us all. So it's no surprise that some of the most promising discoveries around diagnosing, treating, and even curing brain disorders are made in Ontario, including the one we're going to hear about in a few minutes. The opportunity comes in getting faster and better breakthroughs to patients, to markets, and to the world. The OBI has no labs. We don't do research ourselves. We bring together the key players, from researchers and clinicians to patients and companies large and small, to speed things up, to do science differently. One of our mandates is to showcase to the public the latest advances in brain science, and that's why we're here this morning. That's why I urge you to join the OBI community, bookmark our website, braininstitute.ca, and follow us on social media. You can see our Twitter account on the screen beside me. Now, I want to welcome a member of the board of directors of the OBI who's going to introduce our speaker, Dr. Jonathan Downar, and our moderator, the Globe and Mail's Andre Picard. Valerie Pringle is known to you all very well as a journalist and broadcaster, but she's also one of the most effective mental health advocates in the country. Her volunteer work on the board of the Center for Addiction and Mental Health Foundation comes out of her own family's experience with depression and anxiety. She knows what it takes to shine a light on these shadows. So please join me in welcoming Valerie Pringle.
Anybody who's ever said to me, I miss you in the morning, well, here it is. It doesn't happen very often. But it's an enormous pleasure for me to be here as a board member of the Ontario Brain Institute. These people are the smartest people in the whole world. And Meredith and I sit at these board meetings and go, holy moly. They are the most brilliant human beings, and they are doing such exciting and wonderful things. As David mentioned, I am an advocate. I mean, we started off, my husband and I, as donors to CAMH, inspired by the spectacular Michael Wilson, who's sitting beside me. He's my breakfast date. And, you know, as I became part of a public awareness campaign for them and put a public face on it, talking about my daughter's experiences with mental illness, although, as I said, in my family, like any other family, runs the gamut from, you know, drug addiction, alcoholism, bipolar, you know, just every normal Canadian family. So, you know, I've realized the hunger for openness and also the hunger for hope and good news. And I think that's one of the reasons we're here today. We want to share news, as David said, about the incredible neuroscience that's going on, much of it right here in Ontario. And the two individuals who are going to be speaking to you today are doing a great deal to move this file forward and overcome the burden of brain disorders. The moderator today is the great Andre Picard, who's been with the Globe and Mail for 20 years or so. He's a great author, a speaker, I think considered universally the top health journalist in the country. He takes enormously complex issues, as you read him in the Globe, and shines a light on them and makes them understandable, and has moved health policy and public policy forward on many, many issues. Mental health being one of them first and foremost, but on every health issue. He was named Canada's first public health hero by the Canadian Public Health Association, and also he was named a champion of mental health by the Canadian Alliance on Mental Illness and Mental Health. And he's a stellar journalist. And our speaker, wow, another genius person. Everybody's going, it's not brain surgery. Well, this sort of is, and I'm a little afraid living in this world, but I'm just doing my best. So I'll be so excited to hear what he has to say. Dr. Jonathan Downar received his PhD in brain imaging from Toronto Western, medical degree, University of Calgary, completed residency at U of T, has established his specialized clinic at Toronto Western, which now receives more than 400 annual referrals, using new technologies to treat patients with medication-resistant major depression, bipolar, eating disorders, OCD, post-traumatic stress disorder. He's translating what is going on in cutting-edge research for a new generation of more effective and rapidly acting treatments for patients with brain disorders. And we'll just say this as an aside, but it's critically important, he also participates in the OBI-funded research program CanBind, looking into depression. And this study focuses on depression, aiming to shorten the path from diagnosis to treatment and matching individuals to the right treatment faster. We know that's where we have to go, and that's where we're going. And there is information on those little green tables behind the carrot muffins, David. At the back of the room, if you would like to know more about this. And I should just also mention that Dr. Downar is a co-author of a forthcoming textbook on cognitive neuroscience from Oxford University Press. It's our great pleasure to have Andre Picard and Jonathan Downar here today, but first of all, let me welcome to the podium Dr. Jonathan Downar.
Well, thank you very much for all of the kind introductions, and thank you all for coming at such an early hour to come in here. I'm very honored that you've all arrived. Thanks also to everybody who introduced me for not pointing out that all of my depression patients have to come and see Dr. Downar when they come for treatment. Make things more confusing, my assistant's name is Sunny, so that makes it easy. As Canadians, one of our greatest and proudest achievements, I think, is universal health care. The only problem is that if your illness is a mental illness, and I think anybody in this room who's ever tried to find a psychiatrist for themselves or for a loved one or so on, would agree with me that universal health care, at least for mental health, is a dream that we are still struggling to achieve. Am I right about this? Okay. I used to think my job as a clinician scientist was to use all of our tremendous advances over the last 20 years to develop more effective treatments. The problem is that's not what my patients were telling me. All of my patients were asking a different question, not why aren't my treatments working 5% better than they were last year. What they were asking me is, why can't I find a psychiatrist? I'm going to argue that the issue is primarily with the technologies and the kinds of treatment that we're able to deliver in the year 2013. No matter what the size of your economy, whether you're in Norway, Saudi Arabia, Luxembourg, or Canada, we simply would never have the financial resources available to do the kind of psychiatry we're doing and offer that type of care to everybody who needs it. So nowadays, I think my job as a clinician scientist is to develop more cost-effective ways of doing the treatment. And that just comes from pure mathematics. So Let me take you through that a bit. Why is it so hard to find a psychiatrist? Here are some numbers on the screen. The top number is the number of us, Canadians. There are a little over 35 million of us. 1 out of 5 of us during the course of our lifetimes is going to suffer a major mental illness, severe enough that it's going to interfere with our ability to function at work or elsewhere. So that's a little over 7 million. 4,100 is the number of psychiatric MDs we have, psychiatric specialists we have. So if every one of those 7 million people wants to have a psychiatrist, we have about 4,100 people to work with. That number could potentially go up a little bit. It's not going to go up by a factor of 2 or 3 or 5 or 10. There isn't the funding for that. There isn't going to be the funding for that. But the implications of that is that as a psychiatrist, and every psychiatrist in this room and elsewhere, our fair share is 1,800 patients. Every one of us has to somehow provide effective psychiatric care to 1,800 patients. That's just what the numbers tell us. Now, GPs will typically carry in their practice around 2,000 to 3,000 patients. In Ontario, the average, last time I checked, was around 150. So we're off by a factor of 10. And again, I'm going to argue that this is just simply a function of the kind of psychiatry we're able to practice, the things that have to change. If we go back to 1890, the situation was even worse. I'm going to divide it up and call us Psychiatry 1.0, Psychiatry 2.0, and then Psychiatry 3.0. So 1890, Sigmund Freud era, people laying on couches undergoing psychoanalysis. Let's say you're a psychiatrist and you're giving people psychoanalysis, so an hour a day on the couch, 5 days a week though, and you're doing that for maybe a whole year before you're able to move on to the next person. So during the course of a single day, if you do an 8-hour day, you've got 8 patients. And those are the only 8 patients you're going to see for the rest of that year. So your ratio is 1 to 8. I'm not going to argue about the merits or demerits of psychoanalysis. All I'm going to say here is that you can't build a healthcare system out of it that's universal. You will never have enough psychiatrists to do that. In 1960, so a 70-year step forward, some interesting things happened. A whole bunch of new types of therapies like cognitive behavioral therapy and new treatments like sort of medications came out that were able to treat things like schizophrenia and major depression and bipolar disorder. So all of a sudden, I'm going to argue that what those really accomplished were to create a kind of a leap forward, a Psychiatry 2.0, that in terms of healthcare system, what it allowed is for each psychiatrist to deliver reasonably effective care, even though they weren't seeing the person every single day for an hour. Maybe even seeing them, for 30 minutes twice a month or for an hour once a month. What that allows you to do is see more like 120 patients in your practice. And that's closer to what we're running now. Now we're at about 150. So the healthcare system that we are running in 2014 is actually mostly a combination of Psychiatry 2.0 and in many cases still Psychiatry 1.0. There's still a lot of people out there practicing Psychiatry 1.0. And that's the reason that it's so hard to find a psychiatrist. That's all we have. It's not a situation that I'm particularly happy with. Now imagine if, I sometimes draw an analogy to the fracture clinic, which is downstairs at our hospital, which sees hundreds of people. And an individual fracture specialist can see lots of people down there. We don't have a fracture crisis where if a person breaks their leg on a ski slope, we have a fracture crisis in Canada where only 1 in 5 people with broken legs is able to actually get in and get treated. And imagine if that were the situation where the streets were filled with people hobbling around on crutches and sitting in wheelchairs saying, do you know where I can find a good fracturist? I'm looking for a fracturist. And they said, well, until you find one, there's an 8-month waiting list, but in the meantime, my grandmother says if you bound it up this way, or maybe you just need to be stronger and just walk on that broken leg and just do it yourself. This is really your own. We don't say these things for fractures. We would never accept that. And yet, if you look at the numbers, a major mental illness like depression or schizophrenia or bipolar disorder can be more disabling than a broken leg. So I think my job as a clinician scientist, and probably the job of all of us that work in mental health care, is to focus on the central problem. And the central problem is access. What we want to get to is, 70 years on, is Psychiatry 3.0. Some kind of system where, at least for MDs, a single psychiatrist can provide effective care to up to 1,600 patients. Everything I'm going to talk to you about today is directed toward that goal. So it's not really a talk about the brain. It's not really a talk about brain stimulation. All of it is really, how do we get to Psychiatry 3.0? Because the goal should be and must be universal health care for everybody who needs it in the field of mental health. That's what this is all about. So the Psychiatry 3.0 I want us to get to is going to be more accessible, it's going to be more effective. It's going to be more rapid in onset. We're not going to be looking at 2 to 3 months to get better. We want 1 to 2 weeks to get better. And above all, more cost efficient, because we're not going to have 15 times the money to work with. We have to work with what we have. So how do we get to effective care for 1,600 patients per MD? I'm going to start off with treatment-resistant depression, because there is lots of it. 4.7% of the population in Canada will undergo an episode of major depression in any given year. And the problem is that more than a third of them don't get better on conventional treatments. 2% of the population is not the population with depression, it's the number of people with depression we can't treat, that we don't know how to treat. And they're walking around out there right now. In Ontario, that's 275,000 people. So it's a tremendous number, and what's sometimes obscured is the human cost of that. I copied that circle there off of a questionnaire that was done by a patient in my clinic. There are not many disorders in medicine where a person actually says, I'd rather be dead than have this. There are very few disorders, sometimes an end-stage kidney failure or liver failure, but very few disorders where a person says, I would rather be dead than live with this illness. And there's 275,000 people out there who are thinking about this, and we don't know how to treat them. You can't put a cost on human suffering, but you can put a cost on the amount of foregone tax revenue, the direct expenses of hospital and healthcare treatment for these people, the disability payments and social assistance payments to these people. It's $20,000 per case of treatment-resistant depression. So we're looking on the order of over $5 billion a year in Ontario alone. What are the options we have today? Well, not much. If medications and therapy have failed you, the only thing that we currently have left that's OHIP approved is ECT, electroconvulsive treatment. I'm not going to spend a lot of time talking about whether it's effective. It certainly is a very effective treatment. It has a bad stigma associated with the memory effects that are associated with that electroconvulsive treatment. What I'm going to say, though, is that that's the percentage of those people who got ECT last year. In Ontario, it's about 1,600 people. It's less than 1%. So whether you like ECT or whether you don't like ECT, unless we scale it up by a factor of over 100, there will never be enough ECT to treat everybody, even if everybody wanted it. So we've still got 273,400 people walking around out there, and that's the enemy. That's what we have to go after. Enter another kind of brain stimulation, and this is what we practice in our clinic, repetitive transcranial magnetic stimulation. Hopefully some of you have heard about this before. It's actually a technique that's been around since the 1980s and has been used for depression since the 1990s. That butterfly-shaped coil you see there is about the size of 2 sliced bagels stuck together. It's an electromagnet, so there's wiring inside. It can deliver finely focused magnetic field pulses to anywhere in the brain to a depth of about 2 or 3 centimeters. In the background, you'll see an MRI up on that computer screen. We can use an MRI to guide it, and by applying repeated pulses over time, you can strengthen or weaken circuits in the brain that are overactive or underactive. They're not fridge magnets. They're pretty powerful. If you place one of these over the area that moves your thumb or your finger, and Andre, I think you had a chance to do this yesterday. Have any of you ever seen that heritage moment where Wilder Penfield, the neurosurgeon, was stimulating on the brain and getting people's, have we seen this? So you can do this with these coils. You place it over the area that moves your finger, send in a couple of pulses, the person's whole hand will move. The person's whole foot will move. So you're directly stimulating the brain. And this is what it looks like if you were to undergo rTMS. You're sitting in a little chair there. It's like a little dentist chair. There's an MRI in one corner there. You can see there's a little camera in the middle that's tracking the person's head and the stimulator. So we can position these to an accuracy of within 2 millimeters, anywhere in the brain that we want to stimulate. And that allows us to target circuits in a much more finely focused way than therapy or medications for people where therapy and medications aren't doing the job. It's been around for depression since 1994. If you give people 20 or 30 sessions of stimulation, you can actually get more than 50% of them to the point where you've knocked their symptoms down by half. You can get at least a third of them to the point where they say, I don't feel depressed anymore. I'm ready to go on. No long-term adverse effects. There's no memory problems with it. It doesn't wreck your attention or your memory or anything like that. All the effects are short-term. It feels like an elastic band being slapped against your forehead over again. That's one of the downsides of it. 95% of people find it tolerable. You can get a headache afterwards for an hour or two. That usually goes away after the first week. There's a 1 in 10,000 risk of seizure, which is about the same or less than you'd expect with antidepressant medications. And that's pretty much it. Here's the strange thing about it. Health Canada has approved this since 2002. The FDA has approved it since 2008, and there are over 500 clinics buzzing away down in the US treating tons of people. So why don't we have more rTMS clinics in Canada? Well, I'm going to argue once again that the economics have not been favorable up until very recently, and everything that I've focused my research on is to make it a no-brainer, sorry for the pun, to start funding this treatment. So the problem is, with conventional rTMS, there's a person's frontal lobe there, and you're seeing the left frontal lobe being stimulated. 30 sessions of treatment. $250 per session of treatment is the going rate in private clinics in Canada. It's closer to $350 to $400 per session in the US. So $6,000 to $9,000 per single course of treatment. And the other problem is that each session is 38 minutes long. That's a bigger problem than it sounds. It's a problem for the person sitting in the chair that it's 38 minutes. But the problem is it also means that just like in Psychiatry 1.0, I can only treat about 8 people a day per machine. That's a problem. So what do we need to do? There are 4 things we need to fix about rTMS to make it a no-brainer, to make it Psychiatry 3.0. We need the sessions to be faster than 45 minutes, a lot faster. We need the courses to be shorter. We don't want this to be taking 4 to 6 weeks of the person schlepping into hospital every day for treatment. We have to get this down to 1 or 2 weeks. We need more responders. 50% is good, but we want it to be better than that. And finally, we'd like to have a predictive test. We've talked a lot about biomarkers, and one of the key focus of the Ontario Brain Institute is to find markers. Why can't you scan my brain, doctor, and tell me whether this is going to work or not? Well, surprisingly, we're still trying to figure out how to do that. And that's one of the things that with Dr. Sid Kennedy and the other folks at the OBI we're trying to work on. So I'm going to take these one at a time. First one, and this is by far the key. What if we could make rTMS from a 38-minute treatment into a 3-minute treatment? The economic benefits are tremendous of that. First of all, I can schedule patients every 10 minutes. I can do 6 times as many patients treating on a single machine. And that means the cost of rTMS drops 6-fold. Plus, the wait lists increase by a dramatic factor of 6-fold as well. That's what the Toronto Theta Burst trial, it's not just Toronto anymore, we now have UBC getting involved, Montreal may join us, so we have a larger network of clinics. We're getting hundreds of patients, 202, maybe at this point closer to 300, who have major depression where medications and therapy haven't helped. Rather than going for ECT, half of them are going to get the standard conventional protocol they're using in the States, the sort of $9,000 one with the 38-minute treatments. The other half are going to get a different thing. This is what I do as a clinician scientist. We comb through the research and we look for things that might be helpful. It turns out that if you repattern the pulses so they mimic the natural theta rhythms of the brain, it's the theta rhythms that the brain uses to change its own wiring. And if you make the pulses look like the same pattern the brain uses to change its wiring, it turns out that at least in some areas of the brain, there's evidence you can get the same job done in 3 minutes with just 600 pulses. You don't need the 38 minutes to do it. So, what happens if we get out some standard scales, measure their symptom severity, and say, can the 3-minute treatment do the same job as the 38-minute treatment? So I'm going to show you a graph with 2 little curves on it. It's the curve of improvement in symptoms of each person on average with a 38-minute treatment versus the 3-minute treatment. Now here's the thing, we haven't finished the trial yet, so we're still in the blind. We've done about 100 people so far. I'm going to show you our preliminary results. Here are the 2 curves. I can't tell you which is which, but it actually doesn't matter. The outcomes look identical. And if we look at the percentage of people who are getting better, here's what we're seeing. Again, I can't tell you which is which, but it really doesn't matter. The 2 pie graphs look the same. Same proportion of responders, same proportion of remitters, same proportion of non-responders. So this is looking really promising, and there's more and more evidence coming out that these 3-minute treatments are doing the same job. We've been using them for more than 2 years. We've probably treated over 200, 300 people with them at our clinic, and the 3-minute treatments are working just as well as the old 38-minute treatments. So that's transformative. And it's a different way of thinking. I have to thank Tina Buchan and Gilles Marceau from the Edgestone Foundation for pointing this out, that we've been chasing how to get that number 40-odd% up to 45%, and they're saying, what if it doesn't work any better? What if it's just faster and more cost-efficient and improves access? And I'm now a full convert to this belief that improving access is the central problem, improving efficacy is a secondary problem. There's only one thing I'm not happy about. 18 to 20% of people are saying, I feel all better now. I'm not happy with that number. That number needs to be better. I want more remitters. We want rTMS to be more powerful. We want it to be able to do a lot more things than it currently does. So let's go on to problem 2. What if we can make rTMS work for twice as many patients? And for this, I have to turn it back again to the neuroscience. This is where you put on your clinician scientist hat and say, are we really stimulating the right brain area? Now, here's the funny thing about the rTMS literature. That left frontal lobe area that I showed you is the only area that's been systematically studied in 20 years of research. So nobody had ever tried any of the other areas of the frontal lobe. Now, that area was a really good guess for what we knew about the brain in 1994, but it's 20 years later. We've had tremendous advances in neuroscience, and they're actually pointing to a different area, not on the left side, but tucked away right in the middle. It's called a dorsal nexus. It's a little area where 3 different networks of brain activity intersect. There's a network of area that generates bodily, visceral emotional responses. That's the feel behind feelings. There's a reason we call emotions feelings. They have a body feel to them, and there's an area of the brain that generates those feelings. There's another network that is responsible for things like thoughts and inner speech. When you say, oh, I'm so clumsy, why am I always late, why do I always make these silly mistakes, that sort of thing. And there's a third area that's involved in rumination and self-reflection. So whenever you're not in the moment, if at any point while I've talked, any one of you is tuned out, and I'm sure this has happened to everybody in this entire audience. Whenever you tune out from what I'm saying to you right now, that's that middle network there, the self-referential network. You're thinking about something else. And those networks should be on a little bit. They should be on some of the time. But in depression, they're on a lot of the time. So you can't focus on what you're doing as you're lost in thought. And what's worse is these 3 networks are all tangled up together in depression. They've intersected, so your thoughts, your feelings, your emotions are all wound up together in a vicious cycle that you can't get out of. The area that's supposed to shut that process down is that little dorsal nexus area, that red spot in the middle there. That's tucked away in the middle. And what's interesting is if you take that same dorsal nexus area and then you look at hundreds of people with depression and you look at their MRI scans, it turns out that there's actually a loss of gray matter. A very subtle loss of gray matter in that area in people with depression. So if you ask, when we scan people for a stroke, we can see where the stroke is. When you scan someone for depression, you can't see where the depression is. Unless you scan hundreds of people and then hundreds of people who don't have depression and compare them, you can see a very subtle thinning of the gray matter in that area. It's actually been a little bit damaged. It does grow back if you get better, don't worry about that. But it's in the same area here. So this is the neuroscience we had in 2011. And I said, well, why don't we start simulating this area? This area is potentially a little more linked to it. Finally, one last thing that prompted us to do this, at Toronto Western Hospital, you may know that they implant deep brain stimulators for things like Parkinson's disease. They're like little pacemakers. They can turn on and off circuits in the brain. There was a woman who came in for Parkinson's disease treatment, and the surgery is very tricky to do. Sometimes the wrong brain area gets turned off. This area got turned off, and within seconds she started crying uncontrollably. She had lapsed into a depression that she hadn't suffered for years. As soon as they turned off the switch, she recovered from the depression. You could literally turn the sadness on and off with a switch in her case, and that was the area that was being turned on and off when they went and did a scan. So I said, well, let's not turn it off. Let's get a coil on that, and let's turn that area back on again. Now, you need a special coil to do that. You see it's bent. It's sort of, can you see it's bent over so it sits on the forehead like that? But those coils can go deep. They can go very deep within the brain. They can get down to that area. It's got a terrible name. It's called the DMPFC. We were trying to come up with something better for it. I was speaking to somebody at a conference down in San Francisco, and they said, honey, you need to call this the D-spot or something like that. And I wasn't prepared to tell patients we needed to stimulate their D-spots, so we left that one out. But what happens if we do stimulate this is a funny thing. It's not that you get more responders. The number of responders doesn't change, but the difference is that if it works all the way. So if you're going to respond to this, you remit. It's much closer to the action. It's much closer to the centers for emotion regulation. So when we stimulate this area, oh, and by the way, we did do the 3-minute treatment as well as the longer treatments. And yes, we got the same outcomes on both, so we tried both. There's the same issue again. But stimulating this other area definitely gives you more remitters. It gives you more people getting better. I wasn't very happy telling a patient they only had a 20% chance of feeling all better at the end, but for a patient with treatment-resistant depression, I do feel happier telling them that there's a 50-50 chance that they're going to get better and at least a 40% chance that they're going to say, I don't even feel depressed anymore. That I'm willing to work with. There's the 2 curves for that, by the way. You'll notice the upper curve, the white one, is the 3-minute treatment. You'll notice that just by chance, our patients having the 3-minute treatments actually started off more severely ill than the ones who had the conventional treatments, and yet they both ended up in the same place after 4 weeks. So these 3-minute treatments are really doing the job. And we can now say that with these 3-minute treatments, I can get you a 40% chance of remission, 50% chance that you're going to feel at least halfway better. Now, of course, nobody wants to be in the blue pile. Everybody wants to be in the red pile, don't they? So, doc, can't you do a test? Can't you scan my brain and tell me whether it's going to work or not? This is surprisingly elusive. We've been scanning the brain for a really long time. We've been able since the early 90s to demonstrate group differences between people who have depression and people who don't. But to take an individual person, it's like, I don't know, if you looked at, say, hair length, you could say there may be group differences between males and females in terms of hair length, but I can't look at one person's hair and say if there's a woman or a man just based on looking at hair length. That's completely unworkable. So what we've all been struggling to do in the biomarkers field is to say, can I take one individual person's scan and maybe their genes and maybe their protein and the others and figure out whether it's going to work or not? This is still in its infancy. But what we're trying to do is look at their resting state brain activity. What I'm showing you right now is a movie sped up of somebody's brain activity over about 10 minutes of lying in the scanner. Those are those networks that I was telling you about. So there's about 12 of those different networks. Each one does a different job. The brain is a network the way the city of Toronto is a network. And if you've ever looked at a Google Maps of Toronto that shows you all the traffic, has anyone ever used the traffic maps to find their way around and so on? You'll notice those traffic patterns change. And if you look at Friday PM, you'll notice recurring patterns. Every day at Friday around 5 PM, there's this funny pattern on the network. We're going to call that afternoon rush hour. Every day at 9 AM, there's a morning rush hour. On Fridays, there's a cottage pattern. On game day, there's a Rogers Center pattern. There's all these different patterns going on. And so the city runs different patterns to get different jobs done, and the brain runs different patterns of activity to get different jobs done. What depression looks like on a brain scan is not a chemical imbalance. What it looks like is gridlock that doesn't go away. We all know there are cities that get dysfunctional in their infrastructure that have grid. It's happened in Mexico City, Sao Paulo, Beijing, lately in Toronto since they worked on the Gardner. That we've got these long, enduring rush hours, and this is what depression looks like. It's a network that's jammed up, and we've got to get it unjammed. So can we see that if we look at certain patterns of brain activity? This is really preliminary. It's really new. I'm going to share it with you anyway. But I had one of my graduate students pull out 5 people who had not done well with the symptoms. In fact, they'd even got a little bit worse during the course of the treatment, so they declined. We said, let's look at what's going on in the area we stimulate. What's neat is that it turned out you didn't need a PhD in neuroimaging to be able to figure this out. So I'm going to circle the area in green. Can everybody see those areas circled in green? So that's where we stimulated. And if you look at the top one, you'll see it's orange, over-connected to the brain's reward circuitry. Next one, orange, over-connected to the brain's reward circuitry. And down in the lower 3 rows, again, orange, orange, orange. Every one of them over-connected. If you have that pattern, and I see that on your scan before treatment, it looks like this treatment isn't going to do the job. We should go and think of something else. If we can confirm this, it's really preliminary, so I'm sharing this with you early on, but it's looking like it may become a reliable pattern. If we confirm this, and if we can elaborate this with the person's genetics and maybe with machine learning, artificial intelligence algorithms to read these patterns and do pattern recognition, we may be getting close to a reliable predictor. What about people who do get better? Let's look at what their pattern looks like. So here's 5 people who got a lot better. Can we see they're completely different? So orange brain's over here, blue brain's over here. Blue is underconnected. These are the folks who are lacking in the brakes, right? They're having dysregulation. When they try to snap out of things, they just get derailed by them. You need this area to be on in order to snap yourself out of your depression. If you have a blue brain, that means you're not going to get better. If you have a blue brain, that means there's a thing to fix. It means that if we stimulate you, we can turn your blue brain into orange brain, you can actually get better. Notice there's one problem down here. This person here. Can you see the last one here? Uh-oh, orange brain. So my graduate student showed me this and said, well, I guess our system isn't very good because this person shouldn't be getting better, but the scales said they did. And then she told me the person's name. I remember that patient. This person got better on the scales, but only because the treatment made her completely manic. She started spending tons of money. This happens about 1% of the time in rTMS. About 1% of the time it does the opposite of what it's supposed to do. The person became completely manic, spent tons of money, had a romantic entanglement with somebody who wasn't her husband. It almost ended her relationship. And she came and she said, I will never do rTMS again. And I said, well, unfortunately, you were one of the 1% of people who didn't. So the scales were wrong and the scan was right. This person should not have had rTMS. So it's funny. It's the exception that proves the rule. All right, that's 3 out of 4. Here's the biggest one, the biggest thing people complain about with rTMS is not that it hurts, it's not that it's expensive. They say, why do I have to drive in from Ajax every single day for 20 to 30 days to get this treated? And what we really want to do is accelerate it down to about 2 weeks. So what if we gave more than one session a day? This is something a lot of places are looking at right now. I think in a year's time I'll be able to show you, because there's several groups that have studies underway on this, and it looks like giving more than one session does really accelerate it. We gave one person who previously gotten better on rTMS in about 30 sessions. We got her better over 30 sessions of treatment. And then we said, and she came back about a year later. She said, I'm starting to slip again, but I have to go to school in a week. So we offered her 5 sessions a day. Her depression on the scale, so this is her on Monday. So on day 1, here she is up at the top. 37 on the Beck inventory is pretty severe depression. That was Monday morning. Next bar is Tuesday morning. Next bar is, let's see, where are we here? Next bar is Wednesday morning. Next bar is Thursday morning, Friday morning, Saturday morning. So she got better in 5 days. Tougher test, we had another person, this is a physician who was admitted severely depressed and suicidal to the hospital, did not want to undergo ECT. His Beck was a 54. Now the scale only goes to 63, so that's sort of off the charts in terms of extreme symptoms. Monday morning, Tuesday morning, Wednesday morning, Thursday morning, Friday morning, knocked it down to 27, down in half in 5 days. And by the end of the 2 weeks, he was also in remission. We've done this about 25 times now, and we see about 30–40% of the time we're able to do this. So it looks like rTMS isn't necessarily going to take 4 to 6 weeks. We may be onto a treatment that can get people better in 5 to 10 days. And that's the future I'm envisioning for it. An accessible, inexpensive rTMS treatment for all Canadians, treatment resistance in less than 10% of people once we've screened them with an fMRI, remission in 1 to 2 weeks, and using brain imaging for treatment selection. I'm going to wrap up saying that I don't want you to think of this as just something for depression. The circuit we stimulate here is just generally one that's involved in thought regulation. And the funny thing is it's involved in lots of other disorders as well. So if you look at the same brain scans where they look at the thickness of the gray matter, it turns out that that area is also thin in people who have binging and purging behaviors that you see in bulimia nervosa and sometimes disorders like anorexia nervosa with binge purging. Obsessive compulsive disorders, same area turns out to be affected. And most importantly, post-traumatic stress disorder, which is people are now realizing a major problem among veterans, among police officers, among people who have undergone trauma. 1 out of 3 people who undergoes a serious trauma doesn't get out of their PTSD using medications or therapy. It's the same issue. There are veterans who come to my clinic who are veterans of Bosnia. There are veterans who come who are veterans of Rwanda. They've been stuck for 20 years. Nothing is getting them better. And what we're finding is that when you do rTMS at this area, this is completely by accident. All we were doing was treating their depression, but they come in and they spontaneously tell us, my binge and purge behaviors are gone. So if it works on your depression, it also clears up the impulsivity that drives binging and purging behaviors. OCD, here's a person in severe contamination fears. She had to wash her hands dozens of times a day. And that's her hand at the bottom. I'll share you her story. She says, after a day of feeling absolutely defeated, she sent me this picture and said, I pull off this stunt for the first time in several years. And there she is holding one of those grimy subway poles. No sweater-wrapped hand or napkin, and some random guy's hand is pretty much making out with mine, or at the very least flirting. So her depression and her OCD both got better when we did this treatment. I don't want to claim it works for everybody. We still haven't gotten past the 50-50 problem, but when it works, it covers all of the above. All right, final issue. Where do Canadians get this treatment? So where can Canadians currently get publicly funded treatment with rTMS? It's been approved by Health Canada since 2002. Here we are 12 years later. This is where you can get rTMS in Canada as of today, under public health care. Saskatchewan and Quebec. Saskatchewan approved it, I believe, in 2008. It was an easy decision. They didn't have any rTMS clinics at the time, so that was an easy funding decision for them. They have a couple running now. Quebec has a number of clinics, and they're now funding it. There are 2 other provinces where it is, as we speak, under consideration. Alberta, as of April 28, 2014, released a report recommending its implementation. We hope to see that coming to Alberta. Ontario, it is before the same committee as we speak, being considered, with a decision hopefully expected within the next month. So I'm hoping to say that we'll be able to deliver effective and affordable to the system treatment for rTMS. I'm hoping that this will be the future of brain stimulation. I'm hoping it won't look like this, that it won't be science fiction, but that it will be something that everyone in this room or a loved one who needs it would be able to access should they ever do so. So that's the final message. And for anybody who has a loved one with depression, one final message, or for anyone who's been through depression, the last thing I want to leave you with is that things are moving. Everyone says don't lose hope, but I hope what I've shown you today is going to give you some concrete reasons to say things are moving along. We know more today than we did a year ago. We know more today than we did 3 years ago. We have better treatments today than we did 3 years ago. There are a lot of new treatments in the pipeline, not just rTMS. There's a non-invasive version, a milder electrical version that you may be able to take home with you. It's about the size of a pager. That's under development. I'm looking at that coming in the next 3 to 5 years. There are a couple of new medications that look like when they work, about half the time, they clear up depression in 24 hours. Those are currently being under study. There are new options that work by completely different mechanisms than everything we've had for the last 60 years. So remember that this is a moving field. We are not stuck with what we have. I'm sorry it's taking so long. We're doing the best we can. But we are going to hope to have more for you every year than we did the year before. Thanks very much.
Very compelling. I saw the data yesterday and I got to buzz your brain with a magnet and stuff. That was great fun. But I think people in the audience like me are saying, wow, this is compelling. It works at least half the time. It's as good as drugs, which is what most people use now. What's the holdup? Why don't we have this?
What's the holdup here?
Yeah.
I think, to be honest, as I say, there's a funding issue. So rTMS has been expensive up until now, and the numbers haven't been there. It's been hard to persuade people that we should be doing a $7,500 treatment when it's only got a 20% chance of working. So everything I've been working on here is to try and say, let's get it to work for more people, more quickly, $50 to $60 per course per treatment rather than $250, working for a larger proportion of people, and with a test that tells us whether it's going to work or not. So to be honest, as clinician scientists, we had more work to do to really make the economic argument for rTMS, but I think it's been made now.
So how far away are we from that tipping point?
Well, it's tipped in Saskatchewan. It's tipped in Quebec. I'm hoping this summer we'll see Alberta and we'll see Ontario also joining this, and hopefully this will come across Canada. One of the nice things about doing research in this field is that all the Canadian labs that do rTMS, they're a very collegial bunch. We seem to be happy working together in larger communities. We're not competing for funding and that sort of thing. Brain Canada and the other government bodies have actually been very good about encouraging grants where people collaborate, and in fact forcing them to work across sites rather than against each other to do these big studies, these 300 patient, 500 patient studies that are really going to prove that the 3-minute treatments work better, that are really going to prove these technical advances.
So when a government thinks about introducing a new treatment, they think, well, are there going to be savings? Are we going to be able to pay for this? So if I get this magnet on my head, can I stop taking drugs? Can I stop therapy? Is it just going to magically go away with a little bit of magnetic field?
So what rTMS does, we believe, is first of all, everybody who comes to see me in the clinic has tried between 3 and 20 medications without success. Nobody comes in having not tried anything. Most of them have tried therapy, if they can get it. And so rTMS gets them unstuck. It's a great acute treatment. Once they get unstuck, what I tell them, first of all, is now is the time to go and do therapy, to unlearn the habits of thought that have put you there in the first place. Now is the time to address those stressors. Now is the time to go and find that job. Now is the time to go and sort out the relationship that's gotten you stressed up. Now is the time to leave the abusive partner who's been putting you into this state for the last 5 years. So we try and strengthen people's ability for self-control. We're not pushing a happy button. We're improving their own ability to regulate their own thoughts, and we then encourage them to work with that. So it's a synergy rather than a replacement, I would say.
Okay. So rTMS is going to fix the circuits in your brain for a while, but it's not going to fix your marriage magically.
Exactly. What we're trying to do is get you to the point where you can climb the stairs yourself. It's not an escalator ride, it's a stair climb. So,
okay.
Yeah.
Great. And how much further can we take this? You gave us a little hint at the end that maybe we'll be able to do this at home. Are we going to get to the point where we can eliminate the clinic and people can just do a self-treatment? It sounds wacky, but...
Well, so this is just in a perfect world, you wouldn't have to come into a hospital to get these done. We'd have a safe technology where we could apply stimulation to these areas even without using a much cheaper device that a person could apply at home. It looks like such a technology may be available, approved by Health Canada in 2012. There are a couple of different manufacturers out there. You can make these things for about $250. They run off of AA batteries. And rather than blasting the brain with so much stimulation that the neurons fire, they exploit the fact that neurons are always firing all by themselves. And all this does is nudge them with a very mild electrical current, feels like a little tickle, so that the brain's own activity then induces the changes all by itself. And so that's called transcranial direct current stimulation, or TDCS. We really need better acronyms with it, but so
T-spot.
yeah, the T. And again, it's the same issue. Like we're still optimizing the parameters. So we're not sure we have the right brain area for TDCS. We're not sure if we have the right stimulation parameters. I'd say that technology is 10 to 15 years behind rTMS in terms of figuring, but it will get figured out. And it's easier to teach someone how to use it than it is to teach someone with diabetes how to do their own insulin injections. So we think that this technology could potentially be transformative and really cost effective, in fact, potentially cheaper and more convenient than medications.
But doesn't some of this stuff lend itself to quackery? You know, I've seen, don't gamers have things they can stick on their head and it's going to make you smarter and better at killing people online? Or
yes, so we looked at that. So this transcranial direct current stimulation technology can do a lot of things. It's been studied for 20 years. They've noticed that it improves people's reaction times and their working memory capacity. So one company decided that it would be cheaper to just sell it to video gamers and not make any medical claims about it than to go through the expense and trouble of a clinical trial. So it's officially sold, it's not for your depression, it's just to help you play video games. But whether some people end up using it to play depression is not something they police, of course, right? So.
And you know, we're joking about this, but you can't just take a magnet and make yourself better, right? These are powerful, sophisticated machines you have in your clinic.
Well, so this is just it. If you do it incorrectly, the nice thing is, surprisingly, there's not a huge downside. So it's not like with some other treatments where if you do it wrong, you're going to drastically cause massive problems. What you'll probably do is more just give yourself a headache and so on. People are not going to be able to buy these and just take them home. They cost about $150,000 for the whole suite of treatments. So if you want to buy one of these and take them home, unless you've got a pretty large expense account, that's going to be a bit troubling. But one of the things that we're trying to look at here is to make it safe enough that people can use it at home, and furthermore to finish doing the studies that show people how to use it safely and show people how to do it under medical supervision so that the treatment is doing the job it's supposed to do and not causing you adverse effects.
Okay. So you have 4 important things you have to do, improvements you have to do to make this ready for prime time. What's the most important of the 4? Is it targeting who it'll work for best? Is it doing it faster? Is it doing it quicker? Which one is the most?
Right, so again, if I listen to my patients, the biggest problem they talk to me about is access. They're not saying make it 5% faster. What they're saying is, can I get in less than 3 months? And we've tried to stick with a referral time of 2 weeks. And the reason we moved to these theta burst treatments is because our clinic filled up very quickly. Once we opened, within a year, our machine was completely full and there was a lineup starting. We don't like lineups. So we said, let's see if we can get away with the 3-minute treatments. And it turns out they work at least as well, if not better. So that's enabled us to squeeze in. That's enabled us to treat between 30 and 50 patients a day, with one MD working 50% in the clinic and 50% on research. So I think the central problem is to get the treatments quicker so that we can do them in accelerated fashion multiple times a day, and so that we can get people in there and not have wait lists.
But you're really just touching the tip of the iceberg. You're treating very few people. Is it realistic to get a bunch of these $150,000 machines into the offices of psychiatrists in the near future? So
we looked at that, and we wrote an economic analysis that we placed before the Technology Assessment Committee here in Ontario. And we proposed that there are 50 hospitals in Ontario that currently provide ECT services. We went and did the mathematics, and we said that you could treat, you could treat in every one of those hospitals 1,000 to 1,500 patients per year if you open a clinic like the one that's at Toronto Western or like the one that's over at CAMH. Operating a clinic like that costs about $800,000 for all expenses together. So for between $40 to $50 million in a healthcare budget of $14 billion, we can offer this to 40 to 50,000 Ontarians every year. So that would make a reasonable, so it's 0.2% of the budget to treat 2% of the population. So we think that's a winner.
And these are, you're talking about people with treatment resistant, very expensive patients. They don't tend to work. They're in the emergency room a lot of self-harm. So these are very expensive patients.
Well, that was the argument they made. There are some treatments we do on humanitarian grounds because we want to have them. We don't have transplant programs because they save the province money. We have transplant programs because if it's your aunt or uncle or yourself and needs a transplant, we want to have that service available. For depression, there is so much of it that we really have to make an economic argument as well. And what we're trying to say is that here, leaving somebody untreated even aside from the human cost, has a financial cost of $20,000 a year to the system as a whole. Treating them costs, at least with the newer treatments, more like $2,000 or $3,000 per remission achieved. So no matter how you do the calculations, for every $2,000 or $3,000 the government spends on this, you will get someone to remission, right? And so we think that it's cheaper to treat than not to treat, even human considerations aside.
And you didn't, in your talk, you didn't use the C word. We didn't talk about a cure. So people have to come back and get booster shots, if you will. Is that right?
Yeah, so as I said, depression's like a traffic jam pattern in the brain. It's not a chemical imbalance. It's a brain arrhythmia, if you want to think of an abnormal rhythm in the brain. Some of you will know someone who has an abnormal rhythm in their heart, extra beats or skip beats, and that's a recurring condition. If you take medication for it, and you come off the medication, the abnormal rhythm will creep back in there, and the brain is the same way. So in terms of, we have treatments that will put things right, but unless you want to physically go in and structurally alter the entire brain, then doing these treatments is going to be a treatment for it rather than an outright cure where you just take the condition away. Right?
And we know the brain is sophisticated. We can develop, people can be resistant to treatments, to drug treatments after a while. Is there resistance to develop to this? Does the depression say, I know what you're up to, I'm gonna take a different route?
That's actually the good bit. So if it works, it seems to keep working. rTMS does not last forever. It's more like exercise than like surgery. So you'll do a course of it, and then usually somewhere between, the average is about 10 months. The person may say, it's coming back again, I need to come back in. So we'll do a booster treatment in that case. The booster treatments seem to get further and further apart over time, but it does work over and over again.
Now there's a couple of mics. If people, I want the public here to get their word in, so lift your hand if you have a question. And while the mics are running around, I'm gonna ask you one other thing. How much does stigma play into this, where there's this notion, just shake yourself out of it, you're a bit down, you'll get better, well, you don't have to spend all this money. Do you see that unstated or subtly?
Well, so thanks for asking. I'll say three things on that. The first thing is that when a person says snap out of it, that's because they can do it. They can do it because that circuit is on. They have orange brain, they don't have blue brain. That circuit is engaged. When they turn it on, they can regulate their emotions. But, I mean, I have a motor cortex. I can lift my arm up and down because I haven't had a stroke that's taken out that area. So
and I did that with the magnet yesterday.
That's right.
I got your arm going.
So the first thing is that the stigma in part comes from a need to get the word out there that this really is a brain disorder. Nowadays we can really see it on the scans. We can see what circuits involved, what needs to be turned back on. But I think that's only half the battle. The other side of fighting stigma is to actually have better treatments. If you're an employer, if you're a system, you can say, look, and you have an employee who gets depression, is off work 9 months a year, you can say, look, I completely sympathize with your condition. I'm still not going to hire you, right? And that's, it's not right, but it's also not, I think it's naive to think that's not going to happen. So the second half of fighting stigma is to make the thing treatable. I think that's really important. We have to fix it. And if we can find ways to make depression something that's rapidly treatable and reliably treatable, then the stigma part goes away. Oh, you have depression. Just go to the doctor, get it sorted out, take a couple of weeks off. Not, oh, you have depression, I don't want you to talk about it, I need to hide this, and I can't tell my employer because I'll get fired. If it's a treatable thing, the stigma goes away. And so that's the second half of fighting stigma.
Okay. And a big part of it is the recognition that it is a brain disease like any other physical disease.
Just like you saw in the pictures.
Yeah. So where'd the mic get to? I know I saw some hands. Okay, go ahead.
Yes, you mentioned it might be effective in a few other disorders. Unfortunately, you didn't mention schizophrenia or psychosis. Anything to suggest it might work there? Or?
So the question is whether rTMS might be helpful for psychosis or for other tricky diseases like schizophrenia.
Or bipolar, yeah.
Right, and schizophrenia is a notoriously tough one. Looking at the brain, it's not just a rhythm problem or a traffic jam. There is a lot of shrinkage and sort of atrophy that goes on in the brain. One of the early studies of schizophrenia called it a precocious dementia, almost like a sort of a dementia that sets in your early 20s rather than later down the line. So you have to overcome not only sort of a traffic problem, but also a structural problem there. I think rTMS, so far, in answer to your question, no one's figured out how to treat psychosis, the delusions and the hallucinations, using rTMS. My good colleagues over at CAMH are using it to fix some of the things about schizophrenia that medications don't seem to be helpful with. Medications can be helpful with things like delusions and hallucinations in schizophrenia, but the lack of attention, the apathy, the difficulty focusing and concentrating, those so-called negative symptoms, there are areas of the brain that could help with that, and CAMH is studying that. So there are people working on that part of it.
But one of the most exciting conditions you're looking at next is PTSD. We have a lot of soldiers, a lot of police officers, firefighters who suffer from PTSD. This is really promising.
Yeah. So that's one of the areas where we're quite excited about it. For depression, when standard therapies don't work, there are a number of things you can do. For PTSD, if medications and therapy, if you're doing those and you're still stuck, as many people are, then there really is nothing else. You can't give ECT. It doesn't do the job. It doesn't fix it. So for rTMS, what we're seeing is 50 to 60% of people are having fairly dramatic improvements. We had a person who had been taken hostage in Bosnia, who underwent the treatment, and he got a lot better in the first 5 days. On Monday, he came in and looked much worse. And I said, well, what did you do? What's going on? Is it slipped? He said, well, no, I went out to see Captain Phillips this weekend. I thought I'd test myself. It's a movie where a person was taken hostage. We gave him another week of treatment, and he looked fine. And then the next day, he confessed the following Monday that he went with his wife and saw it again. And the second time, after 10 sessions of treatment, he was able to withstand that. So we're cautiously optimistic that I think if I had to look ahead in a crystal ball, what's rTMS really going to be the so-called killer app for? I think that PTSD may turn out to be the thing that rTMS is really recognized as being helpful for.
Okay. I think next time, take away his Scotiabank scene card. Might be a good treatment. So is another question over here?
Yes. What's the root cause of depression? And can it be treated by just medication?
So you're asking what are the roots of depression?
Yes.
And what's the root cause?
Okay. Well, that's a tricky thing. I'm going to say the state of depression on a brain scan looks like a traffic jam that won't go away. It looks like gridlock. The brain's a network the way that the city is a network of streets. There's traffic of pulses in the brain the way that there's traffic of cars on the street, all for doing different functions. When the brain gets stuck in a particular traffic pattern and can't get out of it, like gridlock, that's a lot like depression. The reasons why a brain can get in that are manyfold, and much like a city could get gridlock for many reasons, a brain can get that way too. If you damage the network and have lots of structural damage, potholes, and that sort of thing, a person can become prone to depression. Early childhood experiences that miswire the brain or cause abnormalities can create that traffic jam. Genetics can make some brains more likely to slip into that, just as some cities, by nature of their road network, are more likely to slip into gridlock and can't handle as much traffic. But I think the important lesson is that any brain can fall into this pattern. It's not something that just happens to the weak. Just like any city, if you put enough cars in it, will lapse into gridlock. Some cities can handle more than others, but you put too many cars on the road, any city will shut down. And the same thing is true in depression.
So it's that complex mix of genetics and environment and triggers, and we don't know who's going to get struck.
All of that lays the foundations for what the network of each person's brain looks like, as unique as a fingerprint, as unique as a city, with its own personality. But it's the traffic on that network that determines whether the person's depressed at that moment or not.
Now, for a long time, we've been saying, oh, depression, mental illness is a chemical imbalance. You don't use that terminology. You talk about circuits going awry. Is the chemistry notion, is that gone?
Well, so certainly changes in the brain chemistry can remedy depression, and certainly we do see some chemical changes in the brain in people who have depression. But at the end of the day, what really matters is how those neurochemicals in the brain alter the brain activity. I mean, we sometimes hear about, say, serotonin and serotonin-enhancing medications, but serotonin isn't mood, right? It's not like these little serotonin molecules have little happy faces and float around in the brain and cheer you up. They don't do anything in the brain until they can persuade a neuron to fire its activity differently. And what they do depends on which neuron. If they tickle your visual cortex, you'll see things. If they tickle your brainstem, they'll give you nausea or they'll take away nausea. And if they affect the areas of the brain that are involved in regulating emotions, then they may alter your emotional state. If you skip the neurochemistry and go straight to the circuits themselves, then the neurochemistry becomes sort of a separate issue. Okay. So I don't want to think of it just as a chemical imbalance. I think of it more as a traffic problem. The brain's stuck in gridlock.
Well, that's something that Torontonians can understand, isn't it? Another question
yes.
over here? Yeah.
Can you please comment on how your technique might be applied to other brain diseases such as Parkinson's?
Okay, so that's a great question. So the question is whether rTMS might be helpful in Parkinson's disease. Neurologists invented TMS, and one of the leading TMS researchers in Toronto, the one who trained almost everyone else, is Dr. Robert Chen. He's a movement disorders neurologist who works with TMS in Parkinson's disease. Up until recently, it's mostly been a research tool. I think that there are areas of the brain that could be very useful in Parkinson's disease. I think we can get to them. There are a handful of trials coming out suggesting it may potentially be helpful. So I don't think it's a terrible idea to try it in Parkinson's disease. There need to be a few more studies over the next year or two to see how promising it is. But I do think that that is a potential application. It may not cure it, but again, I think it could be helpful in relieving symptoms once a person's already gone as far as they can with the medications.
And they already use deep brain stimulation for Parkinson and for depression. This is just a different, simpler method.
That's exactly it. So by stimulating deeply within the brain, you can alter the activity in some of the circuits that are abnormal in Parkinson's disease. With the TMS stimulator, we can't get as deep in the brain, but we can still get to the circuit because there are bits of the circuit that are up near the surface. And so I think we may be able to alter that circuit and potentially achieve some improvements. Not what we do in the psychiatry clinic, but I think if the neurology clinic were to build an rTMS center, then they could also do quite well.
Okay. Yeah, so over here on the right.
So you talk about the portion that are still treatment resistant after the rTMS and using an fMRI to identify them. Is that fMRI built into your cost analysis?
Yeah, so that's actually a good point. So if you build and so what are we going to, if we have to do fMRIs on all these people, would it be worth it? The cost of doing one of those fMRIs is between $200 and $250. And that is to make a yay or nay decision on a treatment that's going to cost you $2,000 or $3,000. So for every 2 of those you do, you're going to save yourself 1 futile treatment, save the patient a lot of costs coming back and forth. So I think the economics work out there. You're looking at $400 or $500 to decide whether or not to do a $2,000 treatment for the system and a whole heck of a lot of parking lot fees for the patient. So maybe even higher than that. So.
And so that's good. That makes a lot of sense. And for those treatment resistant who are still treatment resistant or wouldn't benefit from the rTMS, what are these like treatments that are in the pipeline? What do you offer? What can you offer them?
Okay, so there are 2 parts to that question. First of all, what we're learning from these scans is, I hope I can show you, all those people I showed you were depressed by standard diagnostic criteria. What's interesting is that depression doesn't look the same in everybody. There's more than one kind of depression out there. And when we see what we call a bimodal distribution, where you give a bunch of people a treatment and half of them get better and half of them get nothing, what that means is you had more than one kind of person in your group. Not all depression is the same. By stimulating in this one area, we're sorting out one group of them. What I think personally is going on in the other group is that it's a deeper brain area. And in fact, we did a study suggesting the non-responders don't have a dorsal nexus. They've got a ventral nexus. It's down deep in the brain. It's in the brain's reward circuitry itself. The people who seem to be good at treating that are the neurosurgeons. They can get to that circuitry, and they seem better at helping those patients by tunneling down into the brain and implanting a stimulator deep in the brain. We can't get to it with a coil yet. There is a Canadian company that's building a new coil that I think might be able to do the job. But we haven't been able to test that yet. So if we get that new coil, we may start offering it and seeing whether we can help the other half of the people without requiring them to undergo an invasive neurosurgical procedure.